If you look at this question, students, what is told in the problem, there is a matrix defined, all right. A is a matrix defined. It's a 2 cross 2 matrix. B is a matrix defined, and it's also told in the problem that A into B is a null matrix. Null matrix means zero matrix. If that is the case, then 0, if theta minus phi, if at all A into B should result in a zero matrix, then theta minus phi should be equal to what is the question asked. If at all AB has to be defined, number of columns of the first matrix is equal to number of rows of second matrix. That is correct here. So we can define A into B. So I can write like this, cos squared theta into and cos theta sin theta. Here this is cos theta sin theta and sin squared theta. Is it okay? Sin squared theta multiplied by cos squared phi and then cos theta cos phi, cos theta cos phi, cos theta cos phi, and here this is sin squared phi. That should be equal to, see now this part and this part matches, right? So the answer should have the residual order, which is 2 cross 2. So this should be 0 0 0 0 null matrix. What do you say? So we will multiply. How to multiply? First row multiplied by the first column. So I can write cos squared theta cos squared phi plus cos theta sin theta into cos phi sin phi, cos phi sin phi, cos phi sin phi. Similarly, first row multiplied by the second column, cos squared theta, this is cos phi, right? Cos phi, everywhere it is phi. Cos squared theta, cos phi, this is sin phi here, all changes, see properly, all right? Sin phi. Here also this is cos phi sin phi. Is it okay? Sin phi. So cos square theta cos square phi plus cos theta sin theta plus cos phi sin phi. All right. Similarly here, multiply the row and column, cos square theta cos phi sin phi plus sin squared phi cos theta sin theta, cos theta sin theta. Similarly, cos squared phi cos theta sin theta plus sin squared theta into cos phi sin phi, and cos theta sin theta into cos phi sin phi plus sin squared theta sin squared phi, sin squared theta sin squared phi. Now what can be taken out common here? We can take out common here. Cos theta cos phi can be taken out common. Cos theta cos phi can be taken out common. What are we left with? If we take cos theta cos phi common, we are left with cos theta cos phi plus sin theta sin phi, sin theta sin phi. Here also we can take out cos phi and sin theta, cos phi and sin theta. If we take out common, what remains is cos theta cos phi plus sin theta sin phi. Even in the next case, if I take out cos theta and sin phi, what are we left with is cos theta cos phi plus sin theta sin phi, sin theta sin phi. And here also sin theta and sin phi, this is sin squared theta, all right, sin squared theta. Sin theta and sin phi, if I take out common, cos theta cos phi plus sin theta sin phi will be left out. Okay, this part will be equal to what is it? 0 0 0 0. All right. So if you can see here, cos theta cos phi sin theta sin phi, this I can write, This implies everywhere cos A cos B plus sin A sin B can be written as cos of A minus B. So I can write this as cos of theta minus phi that if I take out common, then cos theta cos phi, cos theta cos phi, cos theta sin phi, cos theta sin phi, cos phi sin theta, cos phi sin theta, and sin theta sin phi, sin theta sin phi should be equal to 0, should be equal to 0, 0, 0, 0, 0. Are you getting it? So what can be the implication? This means to say that cos of theta minus phi should be equal to 0. Multiplication by this part into a matrix will give you 0, 0, 0, 0. This implies, further implies, theta minus phi, when will cos value become 0? Cos value will become 0 only when theta minus 5 is an odd multiple of pi by 2 where n belongs to the set of integers. Is it okay? This will be the answer to the question.